By now, you should recognize the term IPM, or Integrated Pest Management, from your reading. So, Integrated Pest Management basically means that instead of just doing a regular by the calendar, we're going to spray herbicide here, pesticide here, and insecticide here, a nematodicide here. Instead of just going by a calendar spray that put a lot of chemicals into our food, the farmers and gardeners are using cultural practices to try to lower the amount of toxicity they put on plants. So we're trying to lower the amount of chemicals. So instead of just doing a calendar spray just because it's that day of the month, we're going to do some different cultural practices to make sure it's really needed. Also, in your reading, I hope you remember that insects typically harm plants by chewing and sucking the juices out, sucking the plant sap, which is its sugar, which is its food, so out of the phloem. But they also harm plants because they're actually making wounds when they do that. When they chew on the plant or suck on the plant, when they pierce it with their little mouth parts, they're actually creating a wound. And anytime you create a wound, you're going to elicit a response. So that means the plant has to use energy to have that immune response. Just like in people, if you get a wound, you're going to have an immune response, even if it's a microscopic scale. The other thing that happens when you have a wound is that you can have an introduction of bad bacteria, an introduction of a virus, things like that. You create an opening for those bad microorganisms. In addition, insects themselves can actually be a vector of a bad microorganism, meaning they carry it from plant to plant. So hopefully you understand what the term vector means. Vector meaning a carrier. So the insect itself can go from plant to plant carrying bad microorganisms, make a little wound by sucking or chewing, and introduce that bad microorganism to the plant. All right, so I just wanted to review that from the book. And let's talk about 6 ways that we practice IPM, 6 practices of integrated pest management. So one is going to be companion plants. Companion plants. Now, when you go out to wherever you go, to a club, a bar, a hangout, whatever, and you're just wanting to chill out and just have a nice, good evening, who keeps the bad people away? Who keeps the undesirable people that you don't want to approach you away? Your companion, your buddy, your pal, okay? So a companion plant is actually a repellent plant. It actually repels pests. So this is the companion that repels pests. So a really strong companion plant, if you don't know any others, you can know this one. Oregano is one. Oregano has a really strong smell to us, right? And it does to insects too, so it's going to repel a lot of insects. And here's probably your biggest companion plant, is rosemary. Rosemary is an excellent companion plant with any garden to keep lots and lots of pests away, even snails and slugs. So rosemary is a really good one. Oregano is a really good one. Marigolds, believe it or not. Marigolds are really a pretty flower. You can have spring marigolds, fall marigolds, and they actually do have some repellent companion plant properties. And also, don't quote me on this, but you can Google it for yourself. I believe you can actually make marigold tea. I believe marigolds are edible, so you can look that up and find that out for yourself. All right, so this is companion plants. That's number 1. Get these down in your notes. Number 2, trap crops. So trap crops are the opposite of companion plants. Companion plants repel, trap crops attract. So in other words, the trap crops are kind of sacrificing themselves for the crop that you want. So you basically plant something that the insect you have a problem with, the insect that wants your crop, you plant something that they like a little bit better, okay? So This could be actually planting the same crop in 2 different dates so that one of them is a little bit younger so that the insects will go to that one, or it can be just planting a different crop that they tend to like better. So that's going to be variable depending on your crop. What does an insect like better than what you're planting? Here's just an example for you that tends to work. If you're planting cabbage and the insects want your cabbage, plant collards maybe out beside it, and the insects tend to like the collards better. But it's going to be a choice depending on what crop you're planting. But that's what a trap crop is. All right, traps in general. So we just said you have to find out what insect is coming to your crops. So that's one purpose of traps. You set out traps and find out what's there. Another purpose is once you find out what's there, you set traps specifically for that insect. Insects are attracted to specific colors. For example, horseflies are attracted to blue. So if I wanted to put out a trap for horseflies, it would be blue. And then they would come and they would drown, or they would be poisoned, or they would stick to some sticky paper, whatever. Flies, just house flies and stable flies, tend to be attracted to the color yellow. Why do you think those little strips, the little fly strips, are yellow? Because that's what stable flies and just regular house flies tend to attract to, is yellow. So if you're going to have a trap, it would be yellow. So beetles, I think some of the beetle pests like purple. The interesting thing is they also tend to like certain shapes and certain heights off the ground. So when you know what your problem is, or if you suspect and you're like, well, I'm going to put up some traps and find out for sure. But when you know what your problem is, you can get traps very, very specific to that species. Excuse me. Lost my marker. All right. So traps are really important. And if you can trap the insects, you actually, that keeps you from having to put down so much pesticide, because you've trapped them and you killed them in another way that's not toxic to your plants and therefore gets in the food source. All right. Number 4, physical barriers. So a physical barrier could be anything from a greenhouse, so you have your walls, to it could be sticky paper. If you put sticky paper down on the bottom at the base of a tree, and some snails or slugs or ants or whatever tries to crawl on the ground, some caterpillars tries to crawl on the ground to your tree, they're going to get stuck on the sticky paper. It could be wire around the base of the fruit tree to keep your macro animals away, your deer, your rabbits, things like that. So a physical barrier is another way to not have to put down so much toxic chemicals. Biological control. So you should know one biological control already. So biological control is using one living thing to control another living thing. And nature will find a way, and we are not always as smart as we think we are. So a biological control all of us should be really familiar with is kudzu. So kudzu was actually imported to our area. It's not native to our area, believe it or not. Kudzu was imported to control erosion. So that was a biological control for erosion. And boy, kudzu loves Georgia, doesn't it? It just really took off here. So now kudzu is overtaking trees. It's overtaking houses. It's just everywhere. So now we have to control the kudzu. So that can be a problem with biological control. If you try to introduce something that's not native to the area, it can actually harm your native species. So we do have to be careful about unintended consequences. A biological control of aphids is what? I hope you said ladybugs, because that would be right. Ladybugs can really clean aphids off your plants really well. And they don't stay around long, but they'll clean them off and then fly away and clean some somewhere else. You can buy ladybugs, believe it or not. A biological control that we use at the stables for stable flies is actually parasitic wasps. Parasitic wasps are tiny, tiny, tiny. You don't even know they're around. They come in a bag of pupa, and you throw the pupa out. And when they come out as adults, they feast on juvenile stable flies. And so that's a biological control of stable flies. The problem that I found with that is that then the ants like to come and be attracted to the pupa that's left, the pupa case that's left behind. So then you got more ants. You know, Georgia is practically on one big ant bed. But anyway, so you just pick your poison. I'll tell you this is not really a biological control, but it's an interesting phenomenon. So I was feeding my horses a chemical called Simplifly that would actually kill the insects in the horse poop. So before the stable flies could actually, when they laid their eggs in the horse poop, before they could become new flies, it would kill them. And it would kill them because it would inhibit their ability to make chitin. You actually feed it to the horses and it would come out in their manure. And any insects that were laid in the manure, ate the manure, anywhere near the manure, would not be able to make chitin, which is the insect's exoskeleton. So one year, this was working so good. People would just compliment me for not having any flies. My barn was just fly free. It was wonderful. And then one year we just had this huge boom of flies. I'm talking about like flies you could not believe, just worse than ever. It was so bad and I complained so much. The company actually sent me 50 pounds of the Simplify to feed the horses to try again. So what was wrong? It wasn't the Simplify. And believe it or not, it wasn't resistance. That was my first thought, that the flies had gotten resistant to it. What it was is because the manure was not the only source of flies. Flies were in compost. Flies were in, you know, the neighbor's garbage or whatever. And in addition to breaking down chitin in the stable flies, anything that touched the manure was not able to form chitin and able to live, the exoskeleton. And so I was actually killing my fly predators as well as my flies. And so I had no biological control. I had no natural biological control of the flies. So any flies that were attracted to the stables from elsewhere were just running wild because there was no biological control left. So I actually killed my biological control that was out there naturally, as well as my predators, or as well as my pests. So think about that anytime you apply a biological control or a chemical, you can have unintended consequences of affecting species you did not mean to affect. All right, so that's really important to keep in mind as a gardener. Okay, number 6, low risk pesticides, or we want to choose the pesticide. Now this could be something that kills weeds, it could be something that kills insect pests, whatever, but we want to choose the lowest toxicity possible. So it doesn't mean we don't have any chemicals on our food sources or our plants, but it does mean that part of IPM is choosing the lowest toxicity possible and not just applying it over and over again just because. You want to wait and see if you have a problem, which means there's a lot of labor involved. It means you have to actually go out and check your crops. You have to actually put traps up. You have to humanly go through and observe what symptoms you might have and catch them before they get too bad. So there is a lot of labor involved, but there's money and labor saved from not just spending it on chemical after chemical and making chemical after chemical application. Now, organic farming or organic gardening includes all of 1 through 5, and you can put down sprays. You can, but they cannot be synthetic. They have to be a natural spray, like something made from marigolds, okay? So we're talking about, what's the word for that? Sorry, can't think of the word right now for it, but there are sprays that are actually made from marigolds that will keep away pests. So if you're doing organic, you can do 1 through 5 and plus non-synthetic sprays. All right. So that is IPM, Integrated Pest Management. I want you to think about how do you incorporate this into your gardening, into your lawn management, okay? And have a great day. I'll see you next video.